Today, we will be graphing polynomial functions. You'll notice from the examples above that there are some common features of polynomial functions. Most noticeably, the curve is a smooth curve. There's no jagged edges. And also you'll notice that at the end, this one goes toward positive infinity, this one toward negative infinity, this one toward positive infinity. And that's something that we call end behavior. So I want to make sure you recognize that as you're graphing, that your function should be smooth, and that the ends of the graph go toward positive infinity or toward negative infinity. So there are a few things we're going to need to be able to find in order to graph our functions. The first thing we'll need is we will find the zeros of the function, and that of course comes from the factored form. And we'll also need to find their multiplicities, which we'll talk about in a little bit. The second thing we'll need to find is the y-intercept. And finally, we'll need to know the shape of the function, and we will use the a value to help us figure out the end behavior. So we'll use the end behavior to figure out the shape of the function throughout. So let's start with an example. First of all, we want to know what the degree of this polynomial is. Over the last few days, we've been classifying polynomial functions, and you'll notice that in this example, we have 3 linear factors, and if we were to multiply all of this out, this x times this x times this x would give us x cubed. But we can just count the linear factors here as well, telling us that this and this and this factor will give us that x cubed as our highest degree in our polynomial. So this function is of degree 3. It's a cubic function. We can also see from the factors what the zeros are. Just like when we did quadratics, we can see that the zeros for this function are when x is 3, when x is negative 5, and when x is 1. So we can plot those values on our graph. When x is 1, when x is negative 5, and when x is 3 are the only places where this graph will cross the x-axis. The next thing we want to find is the y-intercept. In other words, we want to know what is the value of the function when x is 0. So we're going to evaluate and we get negative 3 times 5 times negative 1, which is positive 15. So we know our y-intercept is 0, positive 15. And you'll notice on this graph that there's no markings on the y-axis, and that's so that we don't get tripped up when we're graphing by finding the y-intercept, which sometimes is a very high number. And lastly, we're going to look at the end behavior. So I'm going to look at the a value, which in our example is just 1. That's the value out front that tells us if it's going to be increasing or decreasing. So in this case, our a value is positive, so we know that it's going to be increasing as we go to the right. And that's what we're going to draw over here, that it's increasing toward infinity as we move to the right. Now, as we start to talk about multiplicity, this will get a little bit more complicated. But for this example, we just want to make sure that our function goes through this point, through this point, through this point, and through this point. And that is a good sketch of what our polynomial is going to look like. It's smooth. It goes toward infinity in one direction, toward negative infinity in the other direction. And we have now sketched our first polynomial. So now we're going to talk about what happens with these multiplicities. How does that change how we graph the function? So the multiplicity of a 0 is the number of times its factor appears in the function. And it also tells us what happens at the x-axis. So in our first example, f of x, our zeros would be x equals 3, x equals 2, x equals 6, and x equals 4. The multiplicities on those zeros would just be the power on that factor. So the multiplicity on this 0 is this power. The multiplicity on this 0 is this power. So we can say that the multiplicity on 3 is just 1. It only appears once. The multiplicity on 2 is 2. The multiplicity on 6 is 3. And the multiplicity on -4 is 2. Now you'll notice that if we were to multiply all of those factors out, we'd be multiplying this x by this x, and again by this x, and this x, and 3 times, and then this x 2 more times. So in fact, if we add up all those multiplicities, it will give us the degree of the function. So this is an 8th degree function. The second thing that the multiplicity tells us is what happens at the x-axis. So when we hit the x-axis with an odd multiplicity, we go right through the x-axis and become negative. But when we hit with an even multiplicity, the function kind of bounces at the x-axis. It bounces away. You can think about, like in a quadratic function, if we had x minus 3 squared, it would bounce at the x-axis and turn right back around. It would never go through to the negative side. So if we have an even degree, we get something we call a bounce. And if it's an odd degree, we'll call it a cross. So let's try a couple more finding zeros and multiplicities. In this example of g of x, the zeros are x equals 0 from the first one, with a multiplicity. Also, x equals -2 with a multiplicity of 1. And finally, x equals 5 also with a multiplicity of 1 because it only shows up once. Again, we have 2 x's for x squared multiplied by another x for x cubed and another for x to the 4th. So this is a function of degree 4, or a quartic function. And finally, for our last example of multiplicities, here plugging in a 0 would give us 0, and we have a multiplicity of 3, and also plugging in a -1 would give us 0, and that has a multiplicity of 2 for a total degree of 5, or a quintic function. Okay, I think we're ready to graph an example of a function that has a multiplicity other than 1. Okay, here we go. So we're in factored form. We can see our zeros. We've got 2 of this factor and 1 of this factor for a degree of 3, or a cubic function. Our zeros and multiplicities. Well, we've got when x equals 3, we'll have 0, and that has a multiplicity of 2 because it appears twice. And we have -5 as a 0 with a multiplicity of 1. So I kind of mentioned crossing and bouncing, which sounds kind of weird, but here's the idea. Since the multiplicity of this 0 is even, that means we're going to have a bounce when we get to this 0. Since the multiplicity of this is odd, that means we're going to have a cross when we get to that 0. So let me show you what I mean. I'm going to graph my first 0, x equals 3 here, and I'm going to graph my other 0, x equals -5 here. And I'm just going to make a little note to myself that I am going to bounce here, and I'm going to cross here. And I'll use that in a minute after I know my end behavior. The second thing I need to know is my y-intercept. So again, I'm just finding when x equals 0. So I plug in -2, times 0 minus 3 squared times 0 plus 5. And I get negative 2 times negative 3 squared times 5, which gives me negative 2 times 9 times 5, which is negative 90. So my y-intercept is negative 90, which I'm going to put down here and I'm going to label 0, negative 90. The next thing I'm going to look at is my end behavior. So end behavior is from our a value. And our a value this time is negative 2, which means we're going down at the end of this graph. So over here, I know that at the end of the graph, I'm going to head down to negative infinity. All right, we are ready to start graphing, and we're going to start with that green arrow. We know that the graph has to end down. So we're going to come up to this 0 here, but then it says we're supposed to bounce away, so we're actually not going to go through the x-axis. We'll bounce away from it, down through this point, and then we'll cross through this 0 and come back up here. So I'm just going to add on my arrow down here, and now I have a nice smooth curve. We bounce or don't pass through the x-axis there, and then we come back through and cross through our second 0. And that's our second example. We're going to try one more together where we have to factor, and we'll do lots of practice in class. For our last example, we will need to factor before we can find the zeros. So in this case, the degree is given to us. We're in standard form. It's a quartic function, meaning it has a degree of 4. The zeros and multiplicities. Well, we've got to factor first. So h of x, first I'm going to look for a GCF. And my GCF here is x squared. And I'm left with x squared minus 5x plus 6. But I can still factor out this part. X times x will give me x squared. Negative 3 times negative 2 will give me my 6. And minus 3x minus 2x will give me that negative 5x. So now I can look for my zeros, which are 0 with a multiplicity of 2. 3 with a multiplicity of 1. And 2 with a multiplicity of 1 as well, because there's no exponent on there. We assume it only happens once. We can graph those points, 0, 0, 2, 0, and 3, 0. And I'm going to put little cross and bounce reminders for myself. So let's see. My multiplicity on 0 is even, so I'm just going to put that in a yellow dot. And my multiplicity on 2 and 3 is odd, so I'm going to put a red dot. That's going to remind me that I'm going to cross here, and bounce here. Next, we want to find out what the y-intercept is. So that means we need h of 0, which is just 0 squared times 0 minus 3 times 0 minus 2, which is just 0. So I actually already had my y-intercept. Next, I need to talk about end behavior. Well, our a value here is just 1. So since a is 1, we know that this graph goes up at the end. And we're ready to graph. So I'm going to sketch my graph. I'm going to start at my arrow. I'm going to come back and cross through this 0. Cross through this 0, and then when I come back down and hit 0, 0, I have to bounce away from it. So I'm going to touch that 0 and then just come back. I'm sure you can do a more beautiful graph with your pencil than I'm doing with this pen. So you're going to try one on your own, and I will see you in class tomorrow to practice. Don't forget to answer your survey questions.